Okay, hello everyone. I'm really excited to start off the second day of Capstones. I know how hard we all worked on it, and I'm just super excited and honored to get to share it and to watch everyone. With that being said, my name is Elora Sulej, and my capstone is Room to Grow, Assessing the Urban Forest Across the Long Branch Neighborhood. My internal supervisor was Danijela, and my external supervisor is Judy. Yeah. So this summer, I had the incredible opportunity to work in urban forestry and do an internship. Myself and some colleagues completed tree inventories in Long Branch, and I had really grown to appreciate it and appreciate urban forestry in general. And with that being said, urban forestry involves, it's more loosely defined as the management of resources in urban areas to maximize their ecosystem services. Ecosystem services are essentially just benefits that humans derive from ecosystems. This includes abiotic factors like reducing flooding, reducing the urban heat island effect, improving water and air quality by removing pollutants, and arguably the most important would be mitigating climate change. Some of the biotic factors include decreasing or increasing well-being by decreasing stress, anxiety, and anger. And it's really paramount that our urban ecosystems are protected because of the fact that urban densification is rapidly increasing. So by 2050, it's estimated that about 70% of the entire population will be living in urban areas. So it's really paramount that everyone has equal access to the ecosystem benefits provided by urban forests. But unfortunately, that's not necessarily the case. There's clearly an inequitable distribution in the urban canopy cover. This was mapped through TESA, which is the Toronto Equity Score Analyzer. In Toronto, and on the right-hand side, there's a map of Toronto's score. It has a combined score of 84, and essentially this tree equity score is produced through socioeconomic factors, including things like age, income, and health, and then also ecological factors like canopy cover. So it combines those to produce a score. Toronto score is 84, as I mentioned, which is pretty decent. And I've encircled Long Branch on the bottom there in red, and I've included the tree equity score in Long Branch, which is 90. Heat disparity and health burdens do contribute the most to that score as the socioeconomic factors. And while this is really valuable information, it's really important to have a more finer scale details in order to assess sort of like the impacts of the inequitable distribution of the canopy. And with that being said, we're going to go into Long Branch. So Long Branch is located in the southwest of Toronto. It borders Mississauga and also Lake Ontario. Excuse me. And so I wanted to draw your attention to Lakeshore Boulevard, which is the natural boundary of Long Branch. So anything north of that is considered Long Branch North, and then anything south is the south. And this historical development map of Long Branch tells us when each portion was developed. And in the south section, there's two parcels that were developed. This Long Branch Park and Pine Beach were developed a lot earlier than the other segments. And essentially, these parcels were once home to large resort properties. So it was a large cottaging region for a lot of individuals, and they'd spend their summers there. And in the north right now, it's developing into more townhomes, and there's more zoning issues there. So it's a lot more dense with the population and the parcel sizes as well. So that difference in parcel sizes, ages of trees, and income, among many others, all work to shape the urban forest. So I wanted to look at, given the neighborhood socioeconomic and historical context, I assume that it was likely the quality of the urban forest differs between the north and southern portions of Long Branch. My objectives were to quantify and compare canopy cover between the two regions and to identify any disparities in the tree distribution. I examined the diversity of species, including richness and species composition between the areas, and I evaluated the availability and distribution of growing space. So essentially, I was assessing the quality of the urban forest in the north and south. So Neighbourhoods is a tree monitoring program that is actually in partnership with the University of Toronto, and me and a couple of colleagues had the pleasure of doing tree inventory from June to August of 2025. We collected a lot of information like species ID, DBH, canopy cover, and a lot of different health metrics. The data was analyzed using ArcGIS Pro in our studio. I did Wilcox inside rank tests, descriptive statistics, species richness, Shannon's diversity, Pelot's evenness, and I also did a Spearman's rank correlation. And I also mapped it in ArcGIS. So the first indicator that we're going to look at is canopy cover. To the left, we have tree canopy area per parcel, and that is stratified by region. So south is always going to be green and north is going to be blue. So as you can see, there is a slight difference. The south has about 70 meters squared of canopy cover per parcel, whereas the north is hovering at around 50. For percent tree canopy per cover, the south was sitting at around 16% and the north at 13.5. So slight difference there. And I did I visualized this in the box plots, and I also did statistics. The statistics were not as promising. They showed that I did a Wilcoxon test and the p-values were insignificant for both. However, it is useful to see just at a different scale if there was differences, and there was a bit of a difference. So the south showed a little bit more canopy than the north. I also looked at tree frequency and diversity. So the first being tree frequency, trees per parcel was plotted over here in this box plot. This wasn't as big of a difference. Again, the p-value was insignificant and the mean in the amount of trees per parcel was quite similar. However, when we break that down and look into the species composition, we can see that Thuja occidentalis or eastern white cedar takes up approximately 20% of the total species composition. And in second place here, we have Acer platanoides or Norway maple. And this is, I wanted to point your attention to the Acer platanoides or Norway maple, that's 8.6%. And also Acer negundo, which is Manitoba maple at 6.1%. These two species, as we all know, are noted as having high invasive potential or invasive in the case of Norway maples. And this took up 13% of the total species across both regions. I broke this down further into north and south. And as you can see, most of the invasives sort of lie in the north. We have our two species, Norway maple and Manitoba maple, that represent a decent chunk of this species. In the south, we see the eastern white cedar makes up the majority of the composition. And then you have hibiscus, Japanese maple, and other species such as that. I did look at species diversity as well. The south is a lot more rich in comparison to the north. Shannon's diversity also reveals a higher value, and Pilot's evenness reveals that it's also more even in the north, which means the species are a little bit more uniform, which makes sense. So in terms of invasive species, what happens is in urban areas that are undergoing a lot of development, the establishment of invasive species often happen because of things like disturbance. So the abundance of sort of development and differences in zoning that's happening in the north could have been sort of a driver of that disturbance that could have caused the establishment of invasive species, is what I've postulated and what the literature also agrees in. Parcel size is really important for the urban forest, and I performed a Wilcoxon test to see if there was a difference in parcel size between the north and south. It turns out there is a pretty large and also statistically significant difference. The north has about 420 meters square more parcel area on average than the south. And this is really important just because of the fact that this has implications for the urban forest. So tree growth is often limited when the parcel size is smaller, and there's also less living volume as well. Also having a smaller parcel size for trees to grow is quite damaging and can also cause increased mortality. But I wanted to see if there would be a significant correlation between parcel size and canopy cover. And it turns out there is. So I ran a Spearman's correlation and found that there was a statistically significant difference, or it was significant, and the rho value was 0.498. This indicates a moderately positive relationship between tree canopy area and parcel area. So as you increase in parcel size, the canopy area also increases. This is really interesting. And so essentially, if you have a smaller area per parcel, you're going to have, it's likely that you're going to have less canopy cover. So to summarize, because that was kind of a lot of information, our descriptive statistics did reveal higher canopy area and canopy percent per parcel in the south. It wasn't statistically significant. I'm assuming this was because there wasn't a lot of plots sampled in the north compared to the south, just because of the fact that a lot of the residents either would not want us to do inventory or just simply did not respond to us asking to do inventory. So these were not statistically significant. Again, I believe it's because of the sample size. Tree frequency per parcel did not yield any significant results. However, species diversity and richness are higher in the south. There's a higher presence of invasives in the north, and the parcel size is statistically significant. And parcel size and canopy area are positively correlated. So essentially, the north region, like across all the indicators used to evaluate the urban forest, it's clear that the north displayed more characteristics of a lower quality urban forest compared to the south for all of the reasons I mentioned. And this phenomenon may be attributed to the socioeconomic and historical context of Long Branch. So the once spacious lakeside resorts may have translated to a larger parcel size, thereby retaining the spatial elements that allow for a more higher quality urban forest. And these findings align with the literature that demonstrates that these inequities can persist throughout across many years and embedded in socioeconomic histories. Here's my references. Thank you. I'd like to acknowledge Danijela for being very supportive and for pushing me to do my best. Judy for providing this opportunity for me. I had so much fun in the summer. My field mates, Luna, Simona, and Madeline, and I want to thank my MFC cohort. I love you guys so much. And yeah.
Thank you very much. I did neglect to mention, Elora mentioned it, but Judy Gibson, the chair of the Long Branch Neighborhood Association, was able to make it here through this weather, so thank you for being here. And I will offer you the first question.
Thank you very much. Good presentation, Laura. It was really nice summary of the data presented there. Thank you. My question was the data that you used. Did you only use the data in your evaluation from the summer work, or did you use it from the data from previous works as well in analyzing the difference in the long and self-profile?
So I only used our data from last year just because we could verify it. We didn't choose to use all of the data just because there was discrepancies sometimes in the way that the data was collected and inventoried. So we thought it would be best to just use like the 2025 data.
And I was surprised it wasn't statistically significant, so that probably explains why.
Yeah.
It would have been a difference if you had one across.
Yeah, I think that one of the barriers to actually assessing the north and south is that a lot of the people in the south are, I think they're more not shy, but they necessarily don't like welcome tree inventory as much per se as people in the south. So I think that if we were to sample more plots in the north, it would have revealed a more significant result. But because the sample size was so small, it was hard to tell.
And I was quite surprised to see an absolute difference in biodiversity in the north versus the south, but that is quite a difference. And I guess my question for you, Lynn, you're not with Fairland to you, but what are the implications then as far as moving forward in trying to increase biodiversity in the north part of Long Branch versus retaining it in the south? Do you have any recommendations based on your analysis?
I think it all comes down to, again, like the community, and if people are really interested in diversity and maintaining the canopy, I think that goes a long way. They'll put more effort into actually wanting to like see biodiversity and see changes in species composition. I think it's a lot to do with the attitude, again, of the people that are living there. It's tough to say because the species are gonna like they're there regardless, and they do provide canopy cover, so that's like a tricky question to answer. But I guess just informing them, making them like education, like telling them about like the Long Branch Neighborhood Association, and hopefully they'll come to our tree for free events and then have more biodiversity, things like that.
Great presentation, thank you so much. Elora. I know you've done lots of work over the summer to clean up the data, so thank you so much for that. Along this graph, I think there is a story there, just when you look at the species composition and what you said about people attitude. So when you look at this north, and it was the most dominant species there. What does it tell you?
What does it tell me?
Yeah.
That the most abundant species is a Manitoba maple.
Yeah.
Well, you said it was a forgotten tree. I guess it's just like the tree that it's mostly like between the borders of properties, and like people forget about it. It's just kind of there. maybe people don't put as much effort into maintaining or like wanting to care for their property as much. I'm not sure.
That's exactly because it's a story about where gardening is happening on a parcel. Most likely that's why you have.
Hibiscus. Yeah.
And then you see the forgotten species in the lot. That alone is a story of itself.
Mhm.
Do you think that our results might feel a little bit different if you didn't use parcel size, but let's say we account for the building footprint? And we look like the parcel and building footprint when it was flat.
Yeah, I did do that as well. I think that if we're just doing the parcels that we sampled, it might not show a difference because we didn't sample as many in the north. But when you extrapolate all the parcels, like if I were to subtract the building from all of the parcels, I think it still would show. Because even just visually looking at the map, like there are pretty visible differences in like even the density of the parcels and like their size. I found even when I was looking and when you're actually out there, it's pretty like notable. So I think that that would still hold up if I did the entirety of Long Branch. Yeah.
Well, question then.
Great presentation.
Thank you.
I'm curious, you mentioned earlier on, you prepared growing space between the north and the south. And I'm wondering how you did that.
Like available growing space.
Yeah.
So I originally I didn't include it. Well, I did parcel size, but we also subtracted the building footprint from the actual parcel itself to get the available growing space, like the more like fine-tuned version of that. I did not necessarily include it because I wanted to talk more about like parcel size and how that was a lot larger. But I did do that. That was how I quantified like available growing spaces. I subtracted the building footprint from the parcel size.
All right.
Yeah.
Follow-up question. Part of the committee study for Toronto, identify possible priority planning areas.
Yeah.
Did you look at those data at all in relation to your study?
No, I didn't really compare any like data between like different regions. Just because I find it would be tricky because we do a very like in-depth sort of monitoring like of our trees. Like we have like a huge list of health indicators and a lot of other things as well. So I think it would have been a little difficult to directly compare, but I do know like in Long Branch the canopy is like decent, like with the tree equity score is 90, so it's pretty good, but I think it would be interesting to do that in the future.
More questions? Yes, that's. The presentation is incredible.
Thank you.
So it was you. Yeah, so something that caught my attention when you were going through these slides, if you go back to species, diversity breakdown.
Yep.
I noticed that, oh, sorry, one more slide back. Thank you. I noticed that in the north, there was actually a higher concentration of trees versus those in the south.
Yeah.
And I think it's kind of interesting given sort of what we talked about with this sort of difference between the two. And I was wondering if you could maybe like, based on your own personal insights and that you were seeing in the fields, sort of talk about
Why there's a higher presence of ash?
Yeah, in the north compared to others.
Yeah, so the ash trees that we saw in the north were like pretty poor health actually, which is unsurprising given that a lot of people was sort of like a lot of people don't put as much effort into the trees that are on their property. So there were a lot of ash trees that were like essentially almost dead that we saw. So that's probably what that is from, which again speaks to the people like and how much care and effort they put into their property. The ash trees were mostly like similar to the Manitoba maples, were on like property lines and sort of like the gray areas between properties that nobody really wants to like touch. And so that was where that came from. So they were in really poor condition. And yeah, and I think in the south they probably had them either removed, like they called and had them removed, or they called for like the injections. Yeah.
I guess, to follow up. I might have just missed it, but did you do a comparison of like overall, like trees in the north versus the south? Like, were the majority like healthy, or were they more like declining or dying, and one for the other? I don't know if I'm like missed that.
No, you didn't miss it. It wasn't in my presentation. There's a lot of different health indicators we looked at, like we looked at girdling cracks, like broken branches, defoliation, like the list goes on, conflicts, things like that. And through personal experience, I would say probably that the species in the north were a little bit, like they were struggling a little bit more. They had more visible injuries, and they were generally of lower quality. Yeah.
Thank you so much.
No problem. Thank you.
Thank you, Laura. Amazing presentation.
Thanks.
One question to follow up on that too is that, so in the south there, there's a lot of white cedar.
Yeah.
Why do you think that is?
So white cedar is really popular in the south because it's used a lot as like a hedge or like a border between properties instead of like an actual fence. A lot of people prefer that. So there is a lot of white cedar as like bushes and fence things. Yeah.
Well, let's be a little more like,
Yeah.
But those, if you count those trees, or are they technically shrubs?
Well, technically, a white cedar is a tree, so we counted them as trees. They were in a separate layer, like we did do a separate layer of like trees and like more shrubby species. A lot of them were actually, though, surprisingly pretty giant or tall, so those did contribute to the canopy cover, so we did classify them as like trees, but they were in the shrub layer. Yeah.
One question. Oh, right.
I can also just say it.
Well, you can, but the thing is that people online will hear you. That's why we're using mine. Thank you. Great presentation, by the way. Did a good job.
Thanks.
Kind of just making back on how Pablo was asking regarding the white cedars that you did at the for you. Well, would you be able to speak to the average DBH? I know it's not like within the scope of work, but I was just more so curious anecdotally.
Of the average DBH of the white cedars we saw?
Like, are they just on the bigger side or small side?
Well, it depended. It was very like property dependent. A lot of them were, I'd probably averaging about 5 DBH, but they could range to like 10, 15 if they were on the like larger side. Average probably 5. Yeah.
Any more questions? Oh. Next is Elora. Moving flag.
Accurate presentation.
Thank you.
And I don't have very scientific question, I'm really kind of curious what like the most unique tree or what like you saw. In those sort of
In terms of trees, there's a lot of smoke trees, which I wasn't really as familiar with. A lot of smoke trees, which look really cool. There's one Manitoba maple that went through the fence, and instead of like removing the fence, they just built like a little like frame for it to go through, and it was like on a crazy angle. That was probably one of the more interesting things that I saw. I do think the smoke trees are really cool though. And they have like a different cultivar of Japanese maples that look really lacy. That's also cool to see. So a bunch of cool stuff in the urban forest.
Question. Anything else? Okay, thank you, Elora.
Thank you.